Hello, Miss Walsh here. So let's take a look at rational functions and their properties. You should have completed the table for this, and perhaps if you hit graph, then you saw that these are just functions that are reciprocal and they're just written in different form. Okay, so the goal of the investigation was to see whether you can find a quick way to determine the equation of the horizontal asymptotes. Where do you draw that line without possibly having a calculator and having a chance to graph it? So these should have been your values. I've written them to many decimal points just to see what happens, okay? And so over here in the first one, you can see that as the x's tend to go to the negative, can you see what's happening? We were at 0, negative 0.4, minus 2.87, minus 2.99, and then if you took even smaller values, 2.9999999. And from the positive side, when you're at 1,000, 100,000, then you're getting closer and closer to negative 3. So the horizontal asymptote for this first one is going to be negative 3. So let's just write it in, and then we see whether we can detect the pattern from the equation, okay? In the second one, look, it's at 1.99 from the negative side, 1.9999 from the positive side. It's just over 2. So it's coming in from the top, going at 2.002, 2.0002. So you can see that in the second one, that horizontal line would be flattening out as it tends towards positive and negative infinity. It would be tending out at 2. And finally, in the third one, as we're coming from the negatives, we're coming in from the top. And so 1.52, 1.5002. Okay, and from the positives, we're coming from below. So 1.497, 4.99, 4.99999. And so you can see that we're tending to 1.5, okay? So the task was to see whether we can detect the pattern. So here, negative 3 and 2 and 1.5, and then look at the values. Is there anywhere here that you can see the negative 3, the 2, and finally the 1.5? Just to clear it up, I'm going to put this one here, and now let's take a look. Perhaps you saw, that would be an excellent job if you did, that it's actually the result of dividing the coefficients in front of the x, okay? And we can see in class why that is. But for the moment, just for the shortcut's sake, when you have the expression in this form, it will always work that your equation will always be the numbers in front of the x's. A super quick explanation is basically as the x gets huge, the fact that you would be like adding 2 or taking a 5 off is just not going to make any difference. What's happening is that it's whatever is happening to these really huge numbers. So think about having like 3 billion over a billion, right? That would simplify in large terms speaking just to the negative 3. Okay, so this is your shortcut to remember that you always take the numbers in front of the x's and you divide them in order to get your equation. Okay, the vertical asymptote, which we have touched upon it, right? The vertical asymptote is where the function does not exist. And numerically speaking, equation speaking, that occurs when you try to divide by 0. Okay, so your little shortcut to determining the equation of the vertical asymptote is just to take that denominator, and here it's this, and set it to 0. Okay, so write to yourself of set the denominator to 0. So in the example of the first equation, in order for you to find that vertical asymptote, you want to take this and set it to 0 to see where does it not exist. So you would take the x minus 5, set it to 0, and we see that we get x is equal to 5, and that would be our vertical asymptote. We're going to graph it below in a moment, okay? So again, vertical asymptote, set the denominator to 0. Horizontal asymptote, look at the numbers in front of the x's. So hopefully you discovered that. That would be really cool if you did. Okay, so graphing the function now, we just need our intercepts. You already know how to find the y-intercept, right? For any function, just set the x to 0. So let's do this. So this is going to be, if we substitute 0 into the x, then we would have 0 plus 2. And then this would be 0 minus 5. And this would simplify to 2 over negative fifth. Or this is negative 0 over 4. And I'm just going to put it down right here. It's somewhere here. Just a bit below 0. Okay, let's find the x-intercept. Whenever you're looking for the x-intercept, we always set the y to 0. So we have 0 is equal to negative 3x plus 2. Okay, now to solve this, sometimes a little bit confusing for students, but we basically are going to multiply both sides by x minus 5 first. Okay, and so you can think about as when you bring this up there, the 0 just kind of eats it up. Okay, so in order for you to find your x-intercept, you're going to have this set to 0. And now just last little step of dividing by negative 3. And you can see that it would be positive 2/3. So I'm just going to go ahead and put that positive 2/3 there. It's a little bit small. Okay, let's draw our asymptotes. And you remember that the vertical asymptote is at 5. And do draw them as dashed lines. For me, it's just easier to draw it as a straight line. And remember, our horizontal asymptote was negative 3 right there. Okay, and what you end up with is a situation where you should be able to go through the x-intercepts and the y-intercept and still tend towards those asymptotes, okay? So that's the case here. Now students often ask, well, how do I draw the other leg? And what you can do is you can just take a point just to see roughly where you are. So let's just say, for example, if I take 6, okay, let's just to get a point, just to see where we are, okay? So if I take 6, then the y value would be negative 18 plus 2, and then 6 minus 5. So I would be somewhere at, not a great point that I chose. So at 6, I would be somewhere already really, really low. Of course, I'm really close to the asymptote. So you can just sketch. You can just sketch it, maybe take a bigger x values, but it should just have this symmetry where it's crossing. This is not very nice, okay? So yeah, so that's how you draw these rational functions. So just remember these shortcuts, and hopefully that helped.